Alright, welcome to class. We are going to be looking at this very question. So we are to evaluate the integral of the sine inverse of x dx. So what we are going to be doing, we are going to be applying integration by parts to solve this. Okay, and I'm going to be defining my u, okay, and my dv respectively. So we have the integration to be u dv. So we have the u dv to be equal to uv minus the integral of v du. Okay, so then I have let my u to be equal to the sine inverse of x, and my dv to be equals to dx. So this is what I'm going to be doing. When I do this, I'm going to have my du now. This is the differentiation of a standard integral, which is already given as 1 divided by the square root of 1 minus x squared, okay, dx. That's what this one is. And if I integrate dv, I'm going to have to be equals to v to be equals to x. Okay, so if I plug that into the question, the solution now becomes the inverse of x dx, which is now equal to my uv, which is sine x, multiplied by x. So we're going to have x sine inverse of x minus the integral of my v, which is still x, being multiplied by du, which is 1 divided by the square root of 1 minus x squared dx. So in this case, I'm going to be using my u substitution in the integral side of it. I'm going to be using the u substitution for it. Okay, so when I do that, I'm going to let my u to be equal to 1 minus x squared. Okay, so when I do this, this is going to help me to actually eliminate that other x there. So what I'm going to do now, I'm going to have my du. If I differentiate this, if I differentiate 1, is going to give me negative, so I'm going to have negative 2 x raised to the power of 2 minus 1, okay, dx, which eventually is going to be du to be equal to minus 2x dx. Okay, so I'm going to be putting that in, so don't forget the negative here. Let's just continue. So we are going to have here to be the integral of x now being multiplied by 1 divided by, this is now going to be the square root of u, okay, then being multiplied by my dx now, this is going to give me du divided by negative 2x. So this x is going to cancel this x, so I'm going to have negative 1 over 2 the integral of simply that saying u raised to the power of negative 1 over 2. Okay, so this is what we are having here. So if I integrate this now, I'm going to have a minus 1 over 2 the integral. Okay, let's just integrate straight. If I add 1 to the power, I'm going to have u raised to the power of 1 over 2 divided by 1 over 2 plus c. Okay, so this is what we are going to have. So let's just tidy this up and see what our final answer is going to be. So when I do this, I'm not going to have that part to be, we're still going to bring it. Don't forget there is a negative 1 over 2 here. Then we have the integral, we have our u raised to the power of 1 over 2 divided by 1 over 2. Okay, then sorry, this we have already differentiated. So we have the plus c here, which we are going to put later. So what we are going to, this 2 of course is going to go forward, so we are going to have the expression to look like this is going to be negative 1 now. Since this 2 is going to cancel this, then on this side we are going to have our u, the square root of 1 minus x squared, okay, plus c. So this is what we have on the other side. So when we write the equation, we discover that in this case, the first one we had was x multiplied by the sine inverse of x. Then in this case, we are able to have a negative. So when we bring it back, we are going to have our final answer to look this way. So in this case, we have x sine inverse of x. This negative is going to affect the negative that is there, so it's going to turn into positive. So we are going to have here to now be positive. In this case, we are going to have square root of 1 minus x squared plus c as our final answer. I believe we find this helpful. Thanks for watching. See you in our next video.